You have just tuned in for a very, very special session at our 6 p.m. Featuring James Chen, our CTO from Flexport, and our moderator, Melisa, Tokmak, who's the GM of Document AI. And this session is called Creating the Platform for Global Logistics with Scale AI and Flexport.
Hello, thank you so much, Mookie. Hi, James. How are you doing today?
Good. How are you, Melisa? Nice to see you again.
It's nice to see you as well. So I'm going to start sharing my screen. We have a great presentation for you, and we'll be giving some more information about it as I share it as well. So welcome, everybody. I hope your Tuesday is going great. And we won't hold you here long, but we're going to talk about some super interesting stuff. And today we have a great session planned for you. And we will talk about creating the platform for global trade and through the partnership of Scale and Flexport. And I think as I was thinking about this session, I thought the most interesting part of the story here is to really have a machine learning company like Scale with experience in building infrastructure to help companies and machine learning teams build deployed machine learning, and Flexport, a logistics company, introducing software to a historically pure physical infrastructure company, and the really synergy collaboration in between them as an ML company and a logistics company, and how that partnership is helping modernize global trade. So we'll talk a little bit about here from the Scale side. I am Melisa Tokmak, and I lead our Document AI products at Scale. And then I will move over to James actually for him to introduce himself, but also the company, before we address the challenges in global trade and how we are solving them using machine learning. So Scale have been around for some time, and really what we are trying to do is to accelerate the deployment of AI and providing that machine learning infrastructure to various industries to power their most ambitious AI projects. We support various industries from logistics, of course, financial services, autonomous vehicles, technology companies, the government, and more, like healthcare and more across the board, and partnering with companies like Flexport and all the others that you see here. So I want to move over to James now, my great guest, who is the CTO of Flexport, to introduce himself a little bit and also tell us more about Flexport before moving on to some of the challenges he's seeing in global trade.
All right. Thanks, Melisa. Yeah, as mentioned before, my name is James Chen. I'm the technology officer here at Flexport. What we do is we built the platform for global trade, both in terms of software as well as operations that can help move goods around the world seamlessly. Our company's mission is really to make global trade easy for everyone so we can have more of it. So what that means is really thinking about how can we change the way things work today to really move goods from one country to the other, and really be able to make all the global trade compliance, physical, software coordination as seamless as possible. As of last year, our scale has really gone really big, where we're over $1 billion in revenue, and we ship tens of billions of goods around. But more importantly, one of the things we help out is a lot of our .org initiative is to really sort of help moving critical goods around the world. And of course, more recently right now, we have helped out with many companies, customers, or even government agencies on moving sort of COVID-related goods to really help get things where it's most critical. And here are also some examples of our customers, but mainly, pretty much any company out there that needs to move goods, we're here to help out. Next. Yeah. So, for those who might not be familiar with what is global trade or what is logistics in terms of the industry, but the reason why it's very hard and why Flexport is tackling this problem is that it is a very fragmented industry where we need to help move goods in countries, whether they're big modern countries or sort of emerging ones. And for a typical movement where you pick it up at a country's origin out of the manufacturers, put it on either air or ocean and destination, and do all the customs work, you have more than 10 different parties or companies that have to coordinate with information. And of course, the maturity level of operations technology is very, very different, and even rules. So that's what makes this industry really, really complex. Next. So, there are many things that we have to deal with, but for the purpose of this presentation, one of the most critical things that we have to tackle, right, is really making sure we have high quality data that all 10 plus company needs to coordinate and treat it as the proper truth, so that we can do proper export clearance, import clearance, figure out tax and tariffs. And believe it or not, something that seems to be very simple, but because you're going through all these different parties is really, really, really hard. Therefore, unlocking this data is really, really critical. Next. So in particular, one of the areas of data is really related to sort of document data extraction. Many parts of the world, or even in modern companies or countries where when data gets exchanged between different parties, a lot of times you actually need to handle the physical paper to one party to the other to even give the ownership and title, because that's actually the legal law. Although we're trying to move it all to digital format, but many places you operate cannot. So therefore, you have to deal with so many different variations of common type of documents in different languages, different format, and you try to digitize and normalize that. So that's one of the critical parts we need to tackle. And at Flexport, we're definitely dealing with millions of documents at this point. So having AI, machine learning, and different applications help out is really, really important. Okay, back to you, Melissa.
Awesome. Thank you so much, James, telling us a little bit about some of the challenges that you're really facing. So here, that is exactly where the partnership between Scale and Flexport comes into play to really resolve those issues as they scale. James shared with us that last year, they have gone over $1 billion revenue. And that means, right, more shipments going through and like more documents around it. And they really want to be able to ensure the quality of these documents, the data unlocked from these documents is accurate and is as fast as possible for them to power new products. So that's where we came in and to provide a machine learning solution to be able to achieve that. So a little bit like taking back companies like Flexport, and especially industries that are dealing with a lot of different variable document types, have been trying various methods for the past 10 years to solve this problem. And really, it is a combination of either utilizing, like leveraging people, or leveraging more basic technologies like OCR. However, at that scale that Flexport is, a new solution is required because really something like standard OCR is not really hitting the spot, right? Let's talk about a little bit about why. First of all, when you look through a standard OCR process, you will start with making templates that teach the system what to expect, right? You're seeing over here on the left image, really, that what does that template might look like. You're saying you're going to find a first name on the left upper corner, etc., and teaching the system to really extract that value from those rules that you have set. And then from those rules, you might transcribe the text, which really focuses on taking the characters out of the document and just writing them down without the relationship between different fields or really understanding what those fields mean, right? There are a few problems with this system. Well, number one is that, as James have been talking about, Flexport team is busy, right? So it's very difficult for different the companies to be able to assign really resourcing to create these templates each time the layout of the documents changes or any edge case that might come up, right? I always say, we live in a world that is not perfect. So all these documents we're dealing with are unfortunately do not look perfect, right? They might be a little lower quality, crinkled, their layout might change, the vendors or companies you might be working with might update their layout, or the way it's written really may not look as perfect as this document where you can see like different sections that are clearly identified. So the one problem really with the system becomes your team has to spend a lot of time creating these templates. And really the second one is about the quality, right? So even when you create these rules, the quality really does not get to the levels that Flexport needs, which are really very high, 90% quality, since they're really caring about abiding by compliance and the data they report taken from these documents. So it becomes very important to hit high quality. And of course, overall, just being robust to variability is not supported by the system. So every time there is a new document or a different type, the team has to do the work that ends up being cumbersome. So what we have partnered in this is to be able to go ahead and really create something that goes beyond the OCR, which what we call is adaptive AI, right? How do we build fine-tuned models that generalize different document formats and layouts so that the model can understand these diverse layouts, but also what those words and fields mean and the semantic relationships with those fields. So, and then delivering that output, of course, in the way that will be most helpful and relevant to the Flexport team in any system that they might be using in their own integrations, right? So over here, really what we do is we have already different base machine learning models that can handle a variety of documents and understanding of words. And we partner with a company, and in this case, Flexport, to really get a sample of their documents to really understand the use case and the things they care about, which are very, very different than the other customers we would work with. It really changes according to your use case, and fine-tune those models with a combination of data annotation and different technologies that we employ in the machine learning architecture, and create this adaptable, fine-tuned model as an end result for them to keep sending documents to process via an API. So that's like what we have been developing. So I'm going to stop sharing for a second to turn to another tab for you guys to show a quick demo that we recorded so you can understand that how it might work. Let's see. Okay. So over here, you really see the model interface, right? In this case, this is a bill of lading extraction model. And you can go, and I want to show you that it's robust to variability. So we're going to go to Google and search for bill of lading, find different options. And in this case, we found one that is not empty. So we are downloading that, just something on Google, and uploading it. Normally, this system would be through an API call, which is really a 2-line code that would be implemented to your system. And once it is really in the system, we have submitted the documents, it gets queued and processed by the model, right? Once it's really processed here, it's going to be refreshed in this case. And let's look at the output. And this is an output of the document we have put, really a random document we have found on the internet just to see how it performs, right? So in this case, you'll see this hasn't been even fine-tuned to the requirements of like the customer in this case, because I just literally pulled it off of the internet. But I want to show you how some of the interesting and very complex parts that the model actually catches on, right? So if we scroll down a little bit here, I'm going to stop and show you. On the right, you see all the fields that we're delivering to a customer like Flexport. It is absolutely every field that they might be interested in. And in terms of examples, of the difficult parts that it catches on that is not possible with other systems, you really see on the right column about the measurement and the gross weight. And there are two numbers underneath it. The first one is really about the cubic measurement, and the second one is about the kilogram, right? Like the weight of it. And it's really identifying, it's understanding the words that the first one, it's about the cubic meter and tying that to the measurement title. And the second one is about the kilogram, the weight, and it's tying it to the gross weight, right? And if you look at the description of the item, like this looks very complex. There's words and entries anywhere on the document that you can see randomly enter.
And you can tell it goes across borders too, right? It's not fitting inside the parts of the document where it should be.
Exactly. It goes across the border. And like, if I didn't know anything about these documents, I, as a human, would have a problem looking like, where should I exactly look at, right? But you can see, I think, James, you're the expert here, but it's really picking up in each line item as well, each item, the goods, and which one is the kilogram of the weight, which one is the cubic measurement, and really tying that into it, including the in-words writing at the bottom about the two containers as well. So across the board, I think this is a good example of showing, first, what kind of complex things Flexport has to deal with, and two, how can you build systems, machine learning systems, to deal with these that goes beyond all the systems that our world has until now, to accelerate that process and be able to provide a service to Flexport's customers as fast as possible and at a high accuracy. So I'm going to stop here and go back to what we have been talking about, just to wrap up in terms of our chat. Yeah, so I think to like recap, and I want to hear a little bit more about from James as well, if I don't cover everything here. But really, at the end of this partnership, the problem was, how do we really handle these difficult, complex documents where Flexport needs to extract information to ensure compliance, to give the best service possible to its customers as fast as possible and as accurately as possible. So this partnership really resulted in automating what has been traditionally a very manual process, right? And a cumbersome process. Obviously, like, we want to leverage everybody working within our companies for the difficult tasks that we really need them for, right? Not some of the tedious data entry and extraction processes, because at 2021, we can automate them. And really decreasing the processing time from what it was about 2 business days to around less than 10 minutes, to really be obsessed with that customer, to bring that customer obsession and give the best service. And all the while really satisfying those accuracy needs and providing around and above 94% accuracy with just machine learning models. So I want to emphasize that, like, there is no human involved in these cases, while optionally we can always keep human in the loop over there according to customer needs. It's important to know that this quality is achievable with just models at scale. And really unlocking that data that James was mentioning as well, to power some of the new things that Flexport is hoping to build in terms of analytics and products. But James, kind of turning over to you on anything else that you want to add about how such collaboration together has unlocked more opportunities with the use of AI at your scale.
Yeah, definitely. I think, hopefully people can see the end result of the Flexport and Scale working together, right? For people who have worked with these type of systems or trying to apply AI and machine learning, right? It's a very iterative process on fine-tuning it to get to a point of high results. So, going from 2 business days down to 10 minutes doesn't happen overnight, right? It happens through collaboration of, 1 or 2 months. So I think we definitely, for sure, less than 3 months now, we're able to iterate pretty fast together. But this brings a lot of agility for the business side to say, hey, now I get the data faster Therefore, you have a little bit more time to process and troubleshoot any of the bad data or inconsistent data, right? Versus before, it takes you so long just to get things digitized to get to a point on verifying, hey, is the data good enough to move shipment forward? The other part I think is a little bit more interesting, maybe in the Q&A we can talk a little more, is really about the accuracy. Like, how do we know it's 94%? And obviously for Flexport, from our part, we need to get that to 100% at the end. But the fact that using a typical other sort of techniques or companies we work with, I'll say like 80, 85% is sort of the typical result. But that extra 10% means, 10% of labor force can be reduced to not focus on digitization, but versus reallocate them to troubleshooting and filing. But our goal on the Flexport side, right, is really to make sure that we even take data from other systems, cross-check it, and try to take it to 100% as part of helping our customer move our freight around. So I think those are two really, I think, pretty high quality results. I'm not sure how everybody else is, but from our practice, anything above like 85%, especially over 90%, is huge. And then reducing that time down to less than hours would be great. Here we can do it in minutes, which is awesome.
No, thank you for that. So I actually want to move us slowly to the Q&A, and as we get those questions, like I have a few that I wanted to share with you. So this session, and of course working with someone like you, has been very important to me personally, because when I look back, really one of the reasons I joined personally Scale, because like I really want to see machine learning deployed in real life situations, right? Yep. It's not just like when I was in school, of course, like learning about it and applying it to projects, great. But really it is projects more in the software world, right? But today, when you look into it, the industries, the industries that are affecting our lives every day, every moment, still run on so much inefficiency. And machine learning can really help, right? But it's taking time to really implement that. One of them is, of course, is on logistics, right? Like really the global trade. All of us interface that every day. Like I just got a package like today of something that I ordered, right? And I want to send packages to my parents who are abroad. And when I was moving here to the US, I had to really move everything I had, which is like big. So it had to come in containers, right? When you're moving houses. So it really affects every aspect of our life. And it was very important to me to have these latest technologies be applied to industries like this so it can actually improve our lives, right? Like the day-to-day lives. And Flexport is a great example of it, right? Flexport has been an automation first company from the beginning. And I love that you say, when we talk about this, you say we're building the freight OS. I love that because it really combines two things that you don't hear very often. And the logistics industry relies so heavily on these physical infrastructure, like whether it's ocean carriers or the airplanes or trucks. And of course, you need these physical assets to actually move goods. But can you tell us a little bit more about how you, someone who has a lot of experience, not only in freight, but really software and machine learning systems, have been thinking about automation and AI in that physical infrastructure heavy world, including but also beyond document automation?
Yeah. So, I think many companies have tried, right, to automate the entire global logistics and global trade. And I think, there's many great teams or bodies working together to, digitize, create standards, and to really at least make sure the system side things are connected very well. And I think, as an industry, if you're working with sort of the tier one companies and carriers, they do have technical systems available, although using a little bit older technology, EDI, now they're converting to hopefully closer to real-time API integrations for most of them. You sort of have a mentality, we can get to a point, you can see, getting to the full automation. However, the one thing that's very, very different about building applications and systems for logistics is that physical side. No matter how great your model says, hey, we can predict, the shipment will arrive at this warehouse 3 hours from now. Or, if you think like, how can you not be accurate on estimating a ship going across the ocean that's moving really, really slow? How come you cannot predict when it's actually going to arrive at port and unload, right? So those are things that, I think on the system side, you can do a fairly good job, but factor in machine learning AI to account for the probability of physical defects or physical events, or be able to suck in real events that might affect your model. I think that's like the next level we're working on, because I think the standard predictable models, you can fairly do a pretty good job, but when there's a strike happening right away, right? Like at the destination port, you sort of can tell what happens over there, but what are the upstream impacts of the next 10 container that goes on a ship? Like, what does that strike has an impact to stuff like that? So therefore, almost everything we design has manual override. We assume every part of our system, humans can get in there and change and modify, put in accurate information. And even though we try to automate as much as possible so people don't need to touch it, but you need to have that override because you just never know what's going to happen.
Yeah, I actually really love that. I want to double click that because I have a follow up, and I know there is a question from the audience, which I'll get to about this very subject as well. Before we get on this call, you and I were chatting, and you talked about some of the unexpected things that happen in the world, right? Even when you're having this slow moving ship and unexpected things happen and you have manual overrides, but I want to double click on that. For example, recently Evergreen, right? Like really the ship that was stuck in the Suez Canal. And I'm kind of curious, you guys had to use these overrides as well. How do you handle the unexpected things? And with the use of really the manual overrides, then I'll take it towards a little bit document processing and handle it.
Sure. Yeah. So Suez Canal, it's very unfortunate that the impact of one ship getting stuck has so much economic impact for everybody. Consumers are getting their stuff late, more congestion and cost goes up. But from a technology perspective, what's really interesting is that, for Flexport, we automate a lot of these stats, right? So we sort of automate all the information on, so we know exactly what contains on the ship. We sort of know the impact of all the other ship that's about to go to the channel. But what's interesting and why manual override is really, really important is that in that scenario where you sort of, everybody in the world's watching, so it's a little bit easier to talk about it and relay, is that you sort of know the ship is stuck there, right? It's not moving, okay? and there are other ships who's stuck behind it that's not moving, right? However, through automation, that's the information we sort of get from our upstream systems from the different carriers or other data sources, is that some of them are still sending us information to say the ship is going through the channel, which is a little bit weird. You're like, hey, that thing is really stuck, but why is it still going? And also the other part that's really it caused a lot of headache for us, but because we allow overrides, is a lot of ships have decided to turn and go around Africa, right? Because they sort of made the bet to say, hey, you know what? It looks like we don't know whether it's weeks or months the thing is stuck. We have to move, and the ship will go around. So what's interesting is that through our automation system, some of this thing we can say, the ship is moving in other directions. So via GPS, you can see the physical movement. However, the part that why it's so complex and people might not understand is that although the ship itself is moving, imagine we automate a system that says, hey, the schedule for this ship, what is it, right? So we need to trust the source from the carriers. So I'm pretty sure they're having a busy time to decide whether to change course or not. So meanwhile, our physical our automation says, hey, the schedule's not changed, right? Because that's what we're getting. But we have manual override to say, hey, it looks like it's moving this way. Let's plot and show people the route of going over there. However, because we automate everything, our automation overrides the manual override. So we have to figure out a way to turn that off. But what's really, really interesting as a logistics company like us is, okay, what do we do now, right? Like physical world says, here's the schedule going this way. But the technical system says, nope, it's still going through the same schedule. And you can't overcome that for the sake of our customers to tell them what's happening without that manual override, because on the system side, we cannot count on every systems giving us real-time information timely. So.
Yeah. No, definitely. No, that's great. Actually, this is also very tied to, some questions from the audience that are curious about how do we manually intervene in the case of discrepancy identified in ML output of the document, right? Like if there's any discrepancy, it's not correct. And it really brings it to the quality issue that you have been mentioning before. So kind of from my side, I'll explain, and then you can dive deep into what happens on quality once the documents are delivered, right? Like from our side, there's so many different steps that we have to look at quality, right? It's not really a final check or anything. There are many systems that we have developed from the fine-tuning stage to ensure that the ML architecture is built in the right way and the annotation is done in a perfect degree so that the machine learning models built are at the utmost quality, right? But once they're built too, as you pass through the documents, we implement other quality checks that really range from taking big samples and like checking output blind on what those samples are, building different machine learning models that are focused on really detecting quality and also calculating confidence scores on the output, right? So what we do, like we would align on different confidence scores. In this case, like the highest really that we worked with James and the team. So anything below a confidence score, we have our own human in the loop layer that we would route to optionally, talking with customers that would really fix, let's say that threshold is 90%. So anything below 90% quality and anything above the confidence score would really be passed on. So we ensure we mix a lot of different systems from machine learning models to random sampling to having our own human in the loop layer to ensure that quality depending on the confidence scores we get from the document output. But once they're delivered, right, we ensure they are at the quality that we have agreed. And in this case, right, let's say we deliver 94% quality outputs with our models to Flexport. And over there, James can talk a little bit more about how they ensure the quality.
Yeah, so so our assumption is that, hey, from Scale, we have a really good idea of these data attributes are super high accurate. Ooh, these are not clear, whether it's Scale having people to transcribe it human. But once it comes over to the Flexport side, we cross-check with many other data sources to see if the value in the document is what it's supposed to be. We have commercial invoice, we have packing lists, different bill of lading documents. So essentially within our system, we have many data points that we believe should triangular against whatever document Scale provide back to us. From there, anything that is pretty much match what we expected, we also sort of automate that, right? Essentially, Scale says, you know what, we 95%, 100% believe this is the value. We cross-check with our expected value across our own documents. If it's pretty much, it should be 100% at this point, if it's correct. So we can really automate all that. And then what's interesting is you get to this bucket where maybe the transcription might be a little bit off, or a lot of times on the Flexport side is there are many words that means the same thing, right? And we need to do our mapping to say, yeah, even though the word is I don't know, apparel, but in this case it really means a t-shirt, another one means a sweater or something like that. So we have to our side to really cross-check a bigger range of value that could make it accurate, so that if it's true, we can also try to automate that, right? And then finally you get to a category of information that says, hey, this looks wrong. And sometimes it's actually the source is wrong, right? Or the source meaning the document itself is wrong. So AI Scale did their job, we did our job, but then, oh, you know what? Actually, the value should be 10, not 9 in this document based on all the information we have. And then we kick off a troubleshooting or triage exercise to go back to the source and say, hey, did you drop one by accident, or or did somebody type in the wrong value, right? And then this way we can update the document before we do final filing to government. So so those are things we can handle it. So.
And the beauty of that is actually once you extract these values, right, from documents, that cross-check is like a more simple software problem that you can really just like compare and see where the discrepancy is if they're not locked in and then different data types. So that definitely is important process in this step. So I know we have just a few minutes left. So I thought that we would really finish it finish it up, I want to learn from you a little bit. Where do you see machine learning and AI taking us in the next 25 years or so when it comes to global trade, right? Between global freight optimization and document processing, autonomous vehicles, supply chains, a lot of the other breakthroughs in machine learning. If you can paint us a picture for how all that might come together and how it might look like with AI, that would be a great end to this.
Sure, sounds great. Yeah, I think it's really, really exciting if we can actually apply machine learning and AI across the entire supply chain. Because one of the things that makes things hard, right? Our missions make global trade easy for everyone, right? One part that's hard is that we're trying to create rules on how logistics should work, but reality is exception and things happen all the time, right? So the actual logistics itself is very dynamic, and it's so dynamic that I think until we have machine learning and AI applied to all the systems, it's going to be pretty much impossible for us humans to come up with rules. So imagine a world where you have system that's monitoring the behavior of what people are doing, so that when a disaster happens or some event or a new rule, government policy gets created, right? So instead of reading about that rule, we can look at the behavior of all the different parties changing, and through the actual events that's happening, machine learning is going to say, hey, I think there might be growth of manufacturing capability of apparels in this part of the world. Therefore, you need to get more capacity, whether it's air or ocean, so that you can build a network to help our customers to ship much easier, right? Or another interesting one would be, sort of what you get in like a traffic map nowadays, right? But for logistics, if you know port congestion is starting to happen through behavior, you can start being delayed. And if one or two companies found a different route to actually get their goods through, right, through machine learning, ideally we would love to grab that insight and apply it to other customers and help them route through. So stuff like that, it's really, really hard to see, right? Today, you probably need to call somebody and figure out what it is and then set it up. But hopefully through machine learning, you're looking at the entire world at the same time, where insights are surfacing and you're just verifying it, versus trying to do it the other way today, where you're trying to come up with the rule to say, here's how it should happen. So I don't know. I think it's going to be endless possibilities once we can achieve that.
Thank you so much. Thank you so much, James. And thanks for everyone joining and hearing about how a domain expert like Flexport comes and combines forces together with a machine learning company like Scale to modernize global trade. And Mookie, back to you.
That's awesome.